Okay, for this problem we've got 48 old coins consisting of nickels, dimes, and quarters. And if you added up how much they're worth, just from their face value, $7.20. However, a coin collector is offered $7 for each nickel, $5 for each dime, and $20 for each quarter. They're from 1929, it's old coins. The total value the coin dealer is offering you is $585 for all these coins. So the question is, how many of each coin do you have? So, well, let's let n equal the number of nickels. Let's let d equal the number of dimes. And let's let q equal the number of quarters. Then we can start writing equations involving these quantities. To begin with, the number of nickels plus the number of dimes plus the number of quarters is 48, because there's 48 coins altogether. The face value, there's 5 cents for each nickel, plus 10 cents for each dime, plus 25 cents for each quarter. The face value is $7.20, or 720 cents. The final equation deals with how much the coin dealer is offered for each of these coins. The nickels are $7 each. The dimes are $5 each. The quarters are worth $20 each. And the total amount all those coins are worth is $585. So now we have three equations with three unknowns. I would like to first do something to make these numbers smaller. So I'm going to divide this equation, everything divided by 5, just to make the numbers smaller. So when I do that, I'm going to copy all these equations over again. N plus D plus Q equals 48. Now dividing by 5, we end up with N plus 2D plus 5Q equals 720 divided by 5 is 144. And finally the last one is 7N plus 5D plus 20Q equals 585. So these are the three equations with three unknowns that we'll now use Cramer's rule to solve. First we need to find the determinant D, so let's calculate that. D is equal to the determinant of the matrix of coefficients on the left side here. The n's, the coefficients of n are 117. The coefficients of the D is 125. And the coefficient of Q is 1520. So finding the determinant of this, we copy the first two columns again. So 1, 1, 7, 1, 2, 5. And now we start our process of multiplying down diagonals. So we have 1 times 2 times 20. 1 times 2 times 20 is 40. The next one is 1 times 5 times 7. 1 times 5 times 7 is 35. And the next one over is 1 times 1 times 5, which is just 5. Now we subtract going the other way, the other diagonals. So we have 7 times 2 times 1 is 14. We have 5 times 5 times 1 is 25. And we've got 20 times 1 times 1 is 20. So that D ends up equaling 40 plus 40 is 80, minus, see what this is. This is 69. 59, sorry. And 80 minus 59 is 21. So D is equal to 21. And next we must find D sub n, D sub D, and D sub q.